this lesson we're going to look at something called completing the square. And before we define what that is, we're going to review some prerequisite skills, things you should be able to do in order to complete the square and use completing the square. So let's first review a few things. So number one, find the x-intercept of f of x. Again, the x-intercepts is when your output is 0. So we're going to say that 0 equals 7x plus 5 squared minus 63. Now, since there's only one x now, to get x all by itself, to solve for x, we need to get rid of all the numbers around it. So we're going to do PEMDAS backwards. And so we did this in a previous lesson. Okay, so we're going to do inverse operations. So step one, outside the parentheses, there's three things. There's a 7 times, there's a squared, and minus 63. So the first thing we're going to do is get rid of the subtracting 63. Okay, so we add 63 to both sides. Okay, so we did that. Next, outside the parentheses, we have a 7 times. So we're going to divide both sides by 7. And still outside the parentheses, now we have exponents. So to get rid of square, we're going to take the square root. Okay, and really what this problem is saying, let me back up, on the right side, when we square something, it equals 9. So there's two ways we can get positive 9. So when we take the square root on both sides, we could have 3 times 3, or we could have negative 3 times negative 3. And then from there, we just subtract 5 all the way around. Okay, so on this one, we have x equals negative 2 and x equals negative 8. Now, I did say x-intercept, so I guess we can put it as a point. So negative 2, 0 is one of them, and negative 8 is 0. And the point of that first problem, again, is that if we have a single variable, it's easy to solve for an equation. All we do is PEMDAS backwards. All right, the second prerequisite is understanding factoring. So on number 2, we want to write that function in factored form. So now that we're dealing with, we have an x squared and an x and a constant. Okay, so on these ones, when that a value, that first coefficient is 1, okay, the technique that's probably quickest, a little bit of guess and check, but we want to find things that multiply to be negative 36. But then their sum has to be negative 5. So you can either think them out or do it systematically. You could do 1 times negative 36, and if we add those together, we get 35. We can do 2 times negative 18, and then you add those together and get negative 16. And you can just continue down that process. 3 times negative 12, and that's negative 6. I'll go up to the top, and then the next one would be what, 4 times 9, and that one does work, right? So 4 times 9, negative 9 equals negative 36, and also 4 plus negative 9 equals negative 5. So those are our two numbers. So we can say f of x equals x minus 9 and x plus 5. Okay, so that's a bit of review. Number 3, same thing, find the factor form. Now this one's going to be a little bit different, so we'll do that same technique. So factors of 16. Okay, so it's got to be negative 1 times negative 16, because that middle term's negative. So negative times negative is a positive 16. When we add those, we get negative 17. Negative 2 times negative 8. If we add those, we get negative 10. 3 does not work, but negative 4 times negative 4. And that adds up to be negative 8. Okay, so there we go. We got that negative 8 right there, and that's what we were looking for. So f of x equals, the two factors are x minus 4 and x minus 4. And how this one's a little bit different in that the two factors are the same. So we can actually rewrite this, not just in factored form, but I guess in vertex form. Okay. So what allows us to rewrite that in vertex form on number 3 is that the factors are the same. So if you look at number 2, the factors are actually different. We have that negative 9 and we have that positive 5. So on those, so we got to ask the question, why or when do we have two factors that are the same? So a couple of things to observe. So number 1, if you'll notice that b term, that middle one, you'll see there it's half of those. Okay, and then also when you take the square root of that. Okay, so that's when we have that. So there's a couple of things to kind of consider. Okay, so here's what we want to do. We want to take half of this, half of b, divide that by 2, and then you're going to want to square it, and that's got to be that number there. Okay, whenever it's in that pattern, that's called a perfect square trinomial. So half of b, square it, and that equals c. So that when we have that pattern, that is when we were able to rewrite that as a factored times itself, so that factored squared. And so that's what we see in that table or text box. Perfect square trinomials have two factors that are the same. You could read that format. So that happens again when we have something squared plus 2 times the first term times the second term, I should say the square root of those, plus that last term squared. So whenever we have that pattern, we can rewrite it as just m plus n squared. So basically, again, what the main thing we need to get out of that is that c, that constant term, when we're dealing with quadratics, but that last term, that has to be half squared of that middle term. Okay, so that's when we have that, or when we force ourselves to do that, that is called completing the square. And that's a process when we're dealing with functions. That is a way of changing it from standard form to vertex form. When we're dealing with equations, it's a technique to move from just one variable, or excuse me, two variables to one variable. And so we'll see that on the next a couple of examples, that we're going to have an equation with two variables like x squared and x to the first and a constant. In order to solve that, we can't have an x squared and an x to the first if we can't factor it. So we have to complete the square to change the format. Now, before we change the format, let's just kind of, to solve equations, let's just kind of review what the pattern of the numbers. So find the value of c, that constant term, to make a perfect square trinomial. So we have number 4, x squared plus 14x plus c. So what does that c have to be in order for us to say that is a perfect square trinomial? And again, it's really simple. You're just going to take this middle term right here, the b value, and you're going to divide that by 2. So this is what c is, and then you're going to square that result. So that's 14 divided by 2 is 7. 7 squared is 49. And that's it. Okay, so if that was 49, if c is 49, we can actually factor that. So if it's x squared plus 14x plus 49, that is a perfect square trinomial. Your practice problems, that's all you have to do. The first ones is just say, what is that c value? If I ask you to factor that, you're going to say, okay, that's x plus 7 and x plus 7. Because when you multiply those, we get 7x times plus 7x, which is 14x, and then 7 times 7, which is 49. Okay, so the same thing on number 5. So just tell me what the value of c is, and you're going to have a few practice problems where that's all you have to do. So again, to find that c term, you're going to take that middle term, negative 3, divide it by 2, and square it. Now, when we're dealing with fractions, you can just leave it there as a fraction or change it to a decimal. I'm just going to leave it there. Negative 3 halves times negative 3 halves. You just multiply the numerators, 9, and then the denominator. So that's the value of c. Now let's apply that into two different contexts. So we're going to solve equations by completing the square, and we're also going to change functions, quadratic functions in standard form, into vertex form. So let's first practice solving equations by completing the square, and I have the steps listed there. So we have an equation. Now there's when we do these, there's simple ones, and that is when the coefficient of x squared, so that's a, that has to be 1 for these steps. We'll talk about maybe later some harder ones, but for today, that's all we'll do. All right, so when a is 1, here are the steps that you need to take. Basically, we want to put the variables on one side and the numbers on the other side. So let me copy down that equation. So we have 38 equals x squared minus 6x minus 2. Okay, so we want to make sure x squared and x to the first are on the same term, so the squared term and the linear term. So, and then the constants we'll put on the other, on one side. Okay, so let's add 2. So we have 40 equals x squared minus 6x. Okay, all right. Now the whole reason we did that is we want to figure out plus what. To force that problem on the expression on the right side to be a perfect square trinomial. And that's really, again, that process that we were just talking about. You're going to take that b value right there, negative 6, you're going to divide it by 2 and square it. Okay, so that's negative 3. Negative 3 squared is 9. So we're going to add 9. Now, since this is an equation, what we do to the right, we have to balance that by doing that to the left. All right, so let's go ahead and rewrite that. So 9 plus 40 is 49. Now, the whole reason why we did that was so that we can factor this problem. Okay, so let's go ahead and factor that. So we need two numbers to multiply to be 9 that add up to be negative 6. And if we do it the right way, it'll always be half that middle term. All right, so right now that's not super helpful in that format because we can't separate those. It's not equal to 0. But since it's the same factor, we can say, all right, it's x minus 3 squared. Okay, so we just rewrote it after we factored it and then just rewrote it. Okay, and so again, the point of why we did that whole process is now we're down to a single variable. And to find the value of x, all we have to do is get rid of all those numbers around x. The numbers around x, well, we have x minus 3 and we have a squared. Okay, so we're going to do everything outside the parentheses first. So the first thing we got to get rid of the square, so we take the square root. And there's two ways of getting 49. There's that's 7 times 7. Also, we have negative 7 times negative 7. Okay, and then to get rid of that subtracting 3, we just add 3. So one answer is x equals 10. And if we add 3 to the other one, we get negative 4. Okay, so again, that process of completing the square, the reason why we do it, it changed that x to the first, or x squared and x to the first, and we got it down to a single variable so that we can use PEMDAS backwards. All right, so let's practice that maybe one more time. So number 7, again, we're dealing with an equation. So the directions say to do it by completing the square. There's other techniques to solve those. So again, our first step is to make sure x squared and x to the first are on one side, numbers are on the other side. Okay, so I'm going to first copy that equation again. So negative 51 minus x squared equals 16x plus 3. So it doesn't matter which side the x's and numbers on. We want x squared to be positive 1. Okay, so on this one, we need to add x squared to both sides. Okay, that'll get the x's on the right, but that means also we need to get rid of those constants. So we're going to subtract 3 from those. Okay, so that is 0. Negative 51 minus 3 is negative 54. Okay, that's 0. Now we can't combine those two. We are adding them, but so we'll just say these are added together even though we can't combine them. Now the reason we did that is because on the right, on this problem, we're going to try to make that into a perfect square trinomial. To do that, again, you take that b value right there. We're going to divide that by 2 and square it. And that's what we're going to add to both sides. So 16 divided by 2 is 8. Squared is 64. Okay, what we do to one side, we do on the other. Okay, and let's just rewrite that that equation. So when we add those two, we get 10. Now, and you could probably combine this step with the next one. Okay, the whole reason we did that is so we can factor it. So we want two numbers that multiply to be 64 that add up to be 16, and that's 8 and 8. Again, that will always be half of b if we completed the square correctly. So the reason we did this is so we got down to a single variable. Now we're just down to x. So to get x by itself, we do PEMDAS backwards. Outside the parentheses, the only thing we have is a square, so we're going to take the square root. Oops. Okay, take the square root of both sides, and we need plus or minus. Now, since we cannot take the square root of 10 evenly, it's not an integer answer, okay, or we're just going to leave it the square root of 10 and leave it as an exact answer. Okay, now, so on this one, there's a couple ways of expressing our answer. So again, x to get by itself, we're going to subtract, subtract 8 from both sides. Okay, and that's 0. So now we have x all by itself. So x is negative 8 plus or minus. We can't combine those, so we'll just leave them separate. Plus or minus the square root of 10. So that's the exact answer right there. So if you're asked to find the exact answer, you could write it that way. You can also write the exact answer separated, so negative 8 plus the square root of 10. or x can equal negative 8 minus the square root of 10. So all those are exact answers. Now, sometimes you'll be asked to go ahead and get a decimal approximation. To get a decimal approximation, you just type it in the calculator. So you do the square root of 10, and then you add a negative 8 to that. Okay, so again, if you do that, that is x is approximately, we'll have to round, and you'll read directions how to round it. I didn't specify in this one, but we'll go to 3 decimal places. Okay, all right, so I did the square root of 10 plus a negative 8. And then on the other side, so that's one approximation, or, and we'll do approximately. So again, we'll do the square root of 10. And so we'll do negative 8, so negative 11.162. Okay, so these are your approximate answers. Okay, so since square root of 10 is not a rational number, it's irrational. All right, number 8, we're going to transition a little bit. So 6 and 7, we were dealing with equations, solving equations by completing the square. Now number 8 says rewrite, now we have a function, rewrite f of x in vertex form by completing the square. Similar process, one slight little change, okay? So I'm going to write down this expression. Okay, now I'm going to leave a little gap here, and I'm going to put plus 5 off to the side, because what we're going to do is we're going to rewrite it a perfect square trinomial. So 5 doesn't work out, so we're going to add something to make it work out. Okay, so again, what we're going to add on this one is half of the b value there, and then we're going to square that. Okay, so this b value right here, we're going to divide that by 2 and square it. Okay, so 8 divided by 2 is 4, 4 squared is 16. Okay, so we're going to add 16 to that equation. Now, we can't just add 16 and have it be the same thing, just like in real life. If I have a certain amount of money, and if I add 16, I have a different amount of money, so it's not the same value. So we have to make it be worth the same amount, the same value. So we can't just add 16 and leave it there. But if I add 16 and then I also subtract 16, I don't change the value at all. So really, I just added 0. All right, so, but the reason we did that is so for those first 3 terms right there, we can go ahead and factor that. Okay, so those first 3 terms, we want 2 numbers that multiply to be 16, that add up to be 8. So that's x plus 4 and x plus 4. So there's 2 of them. So that's the whole reason why we did that. And then that last part right there, we need to evaluate that. Okay, so just simplify that. So 5 minus 16 is negative 11. Okay, so right there, we did the first part. We wrote that in vertex form. And so there's some benefits to do that. One of the benefits is, again, if I ask you what the vertex is, remember that's that opposite of the inside, same as the outside. So there's the vertex. Now the second part, so that's kind of like part A. Part B, find the x-intercepts. So the x-intercepts when your output is 0. By the way, if we did not have part A, you would still need to do part B. If I just asked you what are the vertex, this is one of the techniques to do that. Since there's an x squared next to the first, we can't do PEMDAS backwards. We can't change the format by factoring it, because there's no numbers that multiply to be 5 to add up to be 8, so we can't change it to factored form. There are some other techniques that we'll learn later, but for now, if I just asked you part B and that was it, without any additional information, you should know, oh, I got to complete the square, because I can't do, if I scroll to the top here, I can't solve this without some other technique. So for us, for today, like how are we going to solve that? Last class we looked at changing it to factored form, but we can't do that for every problem. So today's lesson, we're doing it by completing the square. So we already did that to solve that by completing the square. All right, so, and the reason why that's so important, again, we have 2 x's, now we have just 1x. And when we have 1x, we can do PEMDAS backwards. So outside the parentheses, we have a square minus 11, so we're going to add 11 to both sides. Okay, and then we're going to get rid of the square by taking the square root. Okay, so we have that plus or minus the square root of 11 equals x plus 4. And to get x by itself, you subtract 4. And we'll have to read directions on this one. We're going to go ahead and just leave it as an exact answer. It did ask for the intercept, so you can write that a few different ways. You can write it as a point, and that's fine to write it that format, or separate it. So let's kind of review. Again, we're completing the square. We did it in two different contexts. We did it with equations. With equations that b divided by 2 squared, we added it to the left and the right side of the equal sign. But when we did number 8 here, we weren't working with equations, we were working with a function. And when we're working functions, remember the main thing on this one is we're going to add and subtract on the same side of the equation, so we don't change the value of the function. We don't change the amount. So really, like this last one, when we added 16 and subtracted 16, that's really 0, and adding 0 doesn't change the value of that. All right, and then the last example, we're doing the same thing, but this one's a little bit different. Okay, so this one's different in that the a value is not 1, and that changes things just slightly. Okay, so so on this problem right here, we're going to rewrite this in vertex form. So our first step on this one is actually we're going to factor out of the first two terms, we're going to factor out the a value. So that's x squared, and then 6 divided into 60 is 10. Okay, and so when we're doing this vertex form, we're kind of forcing it right there. Okay, if we distribute that, you'll see it's the same exact equation. Okay, so from there, now we want to change that into a perfect square trinomial inside the parentheses. So not much is different right there. We're going to take that middle term, so that negative 10, and we are going to divide that by 2. So negative 10 divided by 2, and we're going to square that. Okay, so that's negative 5. Negative 5 times negative 5 is positive 25. Okay, now we can't just add 25 to something and it have the same value or represent the same number. It doesn't, just like in real life. So if I have 25, or a certain amount of money, and I add 25, it's a different amount of money. So we got to balance that out by subtracting the same amount, so it's the same value. Now, what some students are tempted to do is say, all right, I added 25, so I'm going to subtract 25. The only problem with that is we really didn't add 25, because if you distribute that 6, that is not 25. It is actually 6 times 25. Okay, so that's the big change right there. We're going to subtract. We're going to say a times b over 2 squared. Okay, and really that's true for all the problems, just the a was 1 on the earlier ones. Okay, so we're going to go ahead and simplify that. Okay, so we're going to figure out what that is right there. Okay, so we do 6 times 25 is negative 150, and then subtract that from 144, and we get negative 6. Okay, and then again, we change all this so we can rewrite it as a that perfect square trinomial. The two factors of 25 that add up to be negative 10 is minus 5 minus 5. And there we go. We have that in vertex form now. So again, this last one, whenever we have that a value that is not 1, we have to kind of think about what we're adding and subtracting, whether we're dealing with equations or with functions.